Hello, Assalamu alaikum everyone. Today we will talk about the covalent bonding. And before starting the covalent bonding, I will explain again what is a chemical bonding. Chemical bonding is actually these are the forces of attraction which holds atoms together in a molecule. Okay. For example, you have hydrogen atom. Here we have some hydrogen atom, and hydrogen is from group one. If it is group one, you can check it from your periodic table. It is from group one. It means this group one whole group carry one electron in their valence shell. Okay, so it is carrying the one electron here. Okay, so chemical bond is actually these are the forces of attraction which hold atoms together in a molecule. Okay, so it is a one atom and it is another atom of an hydrogen. Okay, so when both these atoms overlap with each other, for example, now they are actually overlapping. It is overlapping. Okay, one and it is 2. So here you can see one of the hydrogen's electron is represented by dot and other is represented by a cross. So it is known as dot and cross structure. We use this dot and cross for making easy for us to differentiate the atoms and their electrons. Okay, so it is the electron of the one hydrogen atom, and it is the electron of the other hydrogen atom. So now you can see they are actually overlapping with each other, and now they are sharing their electrons with each other. So such a bond which is formed by mutual sharing of electrons, this type of bond is known as covalent bond. And this electron pair which is being shared, this electron pair which is being shared is known as, it is known as shared electron pair. It is known as shared electron pair. Is it clear? So here you can see how a hydrogen molecule is formed. So in nature we know hydrogen gas exists as a H2 molecule, and now they are actually sharing their electrons. So next example is chlorine. So you can see chlorine is from group 7. Remember, you can see it is from group 7. Group 7 means there are 7 electrons. So it is the structure of one chlorine. You can see 7 electrons in the valence shell. 1, 2, 3, 4, 5, 6 and 7. So now I am drawing another atom of a chlorine. Here you can see 1, 2, 3, 4, 5, 6 and 7. Group 7 they carry negative 1 charge. The charge of this group 7 is actually negative 1. So it means they can make one bond easily. Okay. So when they will overlap with each other, when they will overlap with each other like this, now they're overlapping with each other. So one electron from this chlorine and other electron from this chlorine, they will overlap with each other. So it is the one electron from this chlorine and other electron from this. It is a shared electron pair. Okay, so one pair electron is there, it means there is single covalent bond. It will become chlorine. This line means there is a single covalent bond. Okay, there is a single covalent bond. So you can write it here: 1, 2, 3, 4, 5, 6, 7. And here 1, 2, 3, 4, 5, 6 and 7. So we will draw the other electrons. For example, 1, 2, 3, 4, 5, 6 and 1, 2, 3, 4, 5 and 6. Okay, so it is a chlorine molecule. It is actually a Cl2 molecule. Okay, so these electrons, like if they are not taking part in chemical reaction, this electron pair is known as lone pair of electrons. Lone pair of electrons. Okay, if electron pair is available and it is not taking part in bonding, so such a pair is known as lone pair of electron, and this electron pair is known as shared electron pair. So such a bond which is also formed by mutual sharing of electron is known as covalent bond. Okay, so next example is oxygen. We can take next oxygen is like oxygen is the next example, you know, O2 molecule. Now you know oxygen is from group 6. You can check it is from group 6. So it means each oxygen carries 6 electron outermost shell. There are 6 electrons. 1, 2. Draw them in pair form, okay? No need to draw them in separate form. 5 and 6. Now it is a one oxygen atom plus it is another oxygen atom. You can check it here. 1, 2, 3, 4, 5 and 6 electrons here. Okay. 6 electrons are here and 6 electrons are here. So when they will mutually align together, we will get this type of structure. You know it is from group 6. So group 6 mean oxygen is carrying two negative charge. It mean it can make two bonds. Okay, two negative mean it can accept two electrons. It can make two bonds. Okay, so now I will draw their electrons here. So 1, 2, 3 and 4. So here 5 and 6. Okay, so what about this atom? 1, 2, 3, 4, 5 and 6. Understand? So you can see there are 4 electrons. 4 electron mean two shared pairs. So when there are two shared pairs, it means there are two covalent bonds. It means oxygen, it is 1, 2, 3, 4, okay, and 5, 6. It is making this bond with this X and X. Like these are the electrons of this oxygen. 1, 2, 3, 4, 5, 6. So you can see oxygen make oxygen to oxygen double covalent bond. Okay, it is double covalent bond in nature. So the next example is N2 molecule. So N2 actually one nitrogen, its atomic number is 7. Okay, 2 electrons in the first shell and 5 electrons in the valence shell because nitrogen is from group number 5. You can change the group number 5 and it is a group 5 member nitrogen. Okay, so if it is from group 5, it means its charge will be 3 negative. So it can make 3 bonds because it is from group 5. So it can easily make 3 bonds. Okay, so it means nitrogen molecule in N2 molecule, it will make nitrogen to nitrogen triple covalent bond 1, 2, 3. And it is the reason nitrogen is inert. Inert means unreactive gas. It is in 78% in our nature, and it is the reason it is inert because it has triple covalent bond. Okay, so let's draw the structure. It's a one nitrogen. So 1, 2, 3, 4, 5. Okay, another nitrogen here. You can say it 1, 2, 3, 4, 5. Now they will overlap with each other. When they will overlap with each other, we will draw them here because they will make triple covalent bond. So 3 electrons from the one atom and 3 electrons from the other. So 3 electrons, 1, 2, 3. So 3 electrons from here, 1, 2, 3. It is the lone pair of this electron and it is the lone pair of this electron. But in your GCE or IGCSE, you will draw this overlapping like this, like 1 and 2. So now there are actually how many shared electrons are there? 3 pairs are there. One pair, second pair, third pair. So you will draw this one dot, then cross, dot, cross, then dot, and then cross. Okay, so you will draw in this fashion in your exam. Okay, so if you will draw like this 1, 2, 3, then 1, 2, 3, it is a wrong description. Okay, how to draw them? You will draw them first dot, then cross, then dot, then cross, then dot, then cross. Okay, so there are 6 electrons. You can see there are 6 electrons. Okay, so it is the reason nitrogen make nitrogen to nitrogen there is a triple covalent bond and it is inert. Inert mean which is unreactive, which cannot react easily. Okay. So next example is water molecule. How to draw structure of the water. You know, each water molecule is made by two hydrogen atoms. Here one hydrogen, it has one electron. Here we have another hydrogen. It is also carrying this one electron. And there's one oxygen, okay? And you know oxygen is from group 6. You will see this oxygen is from group 6. It means it is carrying 6 electrons. 1, 2, 3, 4, 5, 6. So as I already told you, hydrogen is from group 1. It make only one bond. Oxygen is from group 6. It can make two bonds. Okay. So it is the structure of oxygen central atom. Okay, one electron is here. It is one lone pair of electron. It is another lone pair of electron. It is the one electron and another. Okay, now it is the one oxygen. It is overlapping here. It is the electron of one oxygen. Okay, sorry, hydrogen. Really, my bad. It's a hydrogen. Oxygen, and here we have this oxygen, this electron of this hydrogen. Okay, so how to draw according to your exam? So we will draw like this. It is our oxygen. Here is the one hydrogen. Here we have another hydrogen. So one electron here and other here. Okay. So one electron here, other here. So you can draw there like lone pairs of electron here. Okay. So here we can see these are the lone pair of electron. It will become oxygen, hydrogen, oxygen with their lone pairs of electrons. It is the structure of water molecule. So next we have carbon dioxide. So you know carbon is atomic number is 6. It is from group 4. So their electronic configuration will be 2 electrons in the first shell and 4 electrons in the second shell. Okay. It means carbon has carbon has it has 4 electrons in its valence shell. Okay, 1, 2, 3, 4. So there are 4 electrons in its valence shell. We have oxygen, and you know oxygen atomic number is 8. Electronic configuration will be 2, 6. Okay, so there are 2 electrons in the first shell and 6 electron in the valence shell. Okay, 1, 2, 3, 4, 5, 6. You know carbon is from group 4. So it means carbon can make 4 bonds, and oxygen is from group 6. It means oxygen can make 2 bonds. Okay. So how I will draw them? So it means it is my carbon. It's a carbon, and it is a one oxygen, and it is another oxygen. So one oxygen can make 2 bonds. So I will draw the electrons of this oxygen. It is the first electron of this oxygen. It is the second electron. Okay. Here like this, it is the first electron of this oxygen, the second. Carbon can make 4 bonds. So it is the first electron of oxygen, carbon, second electron, third and fourth electron. You know, it is becoming just like this. Carbon, it is making double bond with this oxygen, and it is making double bond with this oxygen because carbon is from group 4. You know, it is making 4 bonds. 1, 2, 3 and 4 bonds. Carbon 4 bonds are complete. Each oxygen can make 2 bonds. If we talk about this oxygen, first bond, second bond. And if we talk about this oxygen, first bond and second bond. Okay. So now you know oxygen's lone pair of electrons 1, 2, because there are total 6 electrons in valence shell. So they are lone pair of electrons of an oxygen. Okay. So it is the structure of carbon dioxide. It's a linear structure. You need to practice this. You need to memorize as well. Okay. So next we have example of NH3 ammonia gas. So nitrogen is from group 5. Its atomic number is 7. 2 electron in the first shell and 5 in the valence shell. It means you have this nitrogen, 5 electron in the valence shell, 1, 2, 3, 4, 5. Okay, there are 3 hydrogens. Each hydrogen, each hydrogen it has only 1 electron. So I will draw the structure here, one hydrogen, another hydrogen, and the last one is here. So need to draw electron here, okay? With this, they are sharing 2 electrons. So it will become nitrogen like this. Hydrogen, hydrogen, hydrogen with lone pair of electron, okay? It is a bond pair of this electron of nitrogen, and it is the electron of this hydrogen. I hope you understand. So each, you can see nitrogen is making 3 bonds, okay? And each hydrogen is making 1 bond because it has valency of making only 1 bond, okay? It is comfortable with 1 bond. So next example, PA3 is similar to Na3 because phosphorus is also from group 5. Because phosphorus is also from group 5. Just instead of N, you can write it here phosphorus. For example, if I remove this, you can see it is the phosphorus, okay? And 1, 2, 3, because phosphorus also has 5 electrons in their valence shell, and it is the one hydrogen. You can see it here. So one electron is here. It is another hydrogen electron, and it is third electron. Okay, it is just like ammonia. You can see it here. Pair of electron is here. Hydrogen, hydrogen, and hydrogen. So both structures are similar. Actual thing is, if you know the group number of your atom, central atom, you can easily predict the structure, okay? So little bit practice is also required. If you will not practice, then it will become difficult for you guys, but you people need certain practice for this, okay? So the next example is CH4. Example 8 is CH4, methane. It's a methane gas, okay? So carbon is from group 4. So carbon can have 4 electrons in the valence shell. 1, 2, 3, and 4. It's a carbon. Carbon can carry 4 electrons in outermost because it is from group 4. So it is bonded with 4 hydrogens. Is the one hydrogen overlapping with this, another hydrogen, third hydrogen, and it is the fourth one, okay? So now you can draw the electron of the hydrogen 1, 2, 3, and 4. So it will become CH4, some methane, okay? CH4. Very simple, and but this is a frequently asked question for your exam. You can see it is the electron of, you can see electron of carbon 1, 2, 3, and 4. So it is the electron of this hydrogen, okay? We not use these bars in ionic bonding, okay? For example, NaCl is an ionic bond, okay? We cannot write it just like this, Na bond with Cl. It is wrong, okay? Only covalent bond. You can represent only covalent bond with this line. You cannot represent ionic bond with this line, okay? This bar is used for only covalent compounds, okay? So next we have C2H6. Ethane, it is C2H6. So C2H6. It means there's a carbon to carbon bond, like structure is C, then carbon, 3 hydrogens here, 1, 2, 3, and other 3 hydrogens are there, 1, 2, and this 3, okay? So now draw the structure. So first I will draw this carbon, this and this is the one carbon is overlapping with another carbon. You can see it here. Because there's single bond means one electron from here, other electron from 2 electrons. So I will write them here. One electron from here and other electron from here. I'm representing carbon electron with dots, okay? So there are 3 electrons, 1, 2, and 3. 1, 2 and 3. Same thing for this carbon, 1, 2 and 3. 1, 2 and 3. Okay. So each carbon is connected with 3 hydrogens. This is the first hydrogen, it is second hydrogen, and it is third hydrogen. Okay. So now you can draw one electron of this hydrogen, this and this, and same 3 hydrogens will be there. Okay, 1, 2 and there's 3. So it is dot and cross structure for C2H6. Of course, you need a little bit practice. So now it is C2H6. C2H6 means now this carbon to carbon double bond. If there's carbon to carbon double bond, so the number of hydrogens are less. Here we have 6 hydrogens, but here we have 4 hydrogens. Okay, so it is like this. For example, we have carbon and carbon. This carbon is connected with 2 hydrogens, 1, 2. And this carbon is also connected with 2 hydrogens because it's C2H4. But you know each carbon make 4 bonds. If I draw a single bond between them, so one of the bond is still missing because each carbon is making 3 bonds. 1, this is 2 and it is 3. So I need to draw another bond, okay? So now each carbon is making 4 complete bonds. So how to draw the dot and cross structure? It is the first orbit, first carbon, sorry. It is another carbon. So there are 4, 1, 2, 3, 4. So 1, 2, 3, 4. Each carbon is sharing 2 electrons. This carbon is sharing these 2 electrons. This carbon is sharing these 2 electrons. Okay. So here is the one hydrogen is here. Is the electron of this carbon, electron of this hydrogen. So here you can see electron of this carbon, electron of this hydrogen. Same, there are 2 hydrogens here. You can see dot and cross of hydrogen representing with this. And same thing is here. You can see like here and here. It is a dot and cross structure of C2H4. Okay, ethene. It is actually ethene. Okay, you will learn about this in 11th in organic chemistry. So don't be worried about this. Okay, the next one is SO2. Here we have sulfur is from group 6. So sulfur can have 6 electrons in the valence shell because it is from group 6. Okay, oxygen is also from group 6. You know, oxygen is from group 6, it can make double bond. Sulfur is from group 6, it can also make double bond. Okay, so it will make just like this. Structure will be like this. Here, so double bond, one bond, second bond with this oxygen, and just like this, double bond with this oxygen. Okay, so oxygen is from group 6. So 1, 2, 1 and 2. Still oxygen also has lone pair. Okay, 1, 2, 3, 4. So 4 lone pairs. 4 electrons mean 2 pairs. Okay, so 1, 2, 3 and 4. Okay, so how to draw their dot and cross structure? It is sulfur, 2 electrons, 1, 2, 3, 4, 5, 6. It is the one oxygen. It is another oxygen. Okay, for another oxygen, so you can write it here. 1, 2, 3, 4, 5, 6 electron in the valence shell of one oxygen. So 1, 2, these bonds are being shared. 1, 2, 3 and 4. It is the structure for SO2. How to draw SO3? You can just utilize this lone pair as well. Okay, so let me write it. SO3, it will become SO3. Okay, it is structure of SO3. Just like SO2, you can draw SO3 as well. Okay, so what is the final one? H2SO4. So it is H2SO4. You need a lot of practice for this. Okay, I know being a teacher, if you're in grade 9 or 10, then it will become little bit tricky for you to understand. But if you're 11, the final year student, then you should be able to understand the structure. Okay, you can see sulfate group from group 6. 1, 2, 3, 4, 5, 6 electron in its valence shell. Okay, each oxygen can make maximum 2 bonds, so you can see each oxygen making maximum 2 bonds. So let me draw the sulfur first. Okay, here is just like this. It is the sulfur. 1, 2, 3, 4. First oxygen is here, another oxygen. So they are actually making double bond with sulfur. You can see it here. Just like this. For your ease, double bond oxygen. Here we have double bond oxygen. Okay, understand? So if it is double bond, so now I need to draw one electron of the sulfur here. It is here and here. It is overlapping with oxygen. One electron of oxygen is here. Other electron of oxygen is here. Okay. So other electron of oxygen is being shared there with this hydrogen. I'm representing a structure with hydrogen with this, and oxygen is here. It is overlapping with this hydrogen. It is a one hydrogen, hydrogen, oxygen. It is oxygen. It is sulfur. I know it is tricky for you, but the thing is, the more you practice, more you will learn about this. Okay, so it is all about covalent bonding, which is formed by mutual sharing of electrons. And what are the properties of covalent bonds? In your O levels, keep in your mind. Okay, number one, covalent compounds. They have low melting points and boiling points. Number one. Number two, they are bad conductors. They are bad conductors of heat and electricity. Okay, they are not good conductors. They are bad conductors of heat and electricity. And other thing is, you can write like, okay, if we talk about joint molecules, just keep in your mind. Diamond is a giant molecule. Diamond. This is also covalent molecule. Okay, graphite, SiO2, like sand formula. SiO2, what is this? It's a sand. Okay, structure of sand. They are actually giant molecule in your O level syllabus. Okay, and it is the reason they have high melting and boiling point, except graphite. Okay, graphite is soft. It is soft, and diamond is the hardest thing in the world. Hard. Okay, and SiO2, it is also a giant structure, high melting and boiling point. They have high melting points and boiling points. Okay, they have high melting and boiling point, and these three are the giant covalent structures. If you talk about some other molecules other than these, you will write for them. They all are simple molecules, simple covalent molecule. Okay, they all are simple covalent molecules. Okay, so just you have to memorize diamond, graphite, SiO2, or sometimes buckyball as well. Okay, buckyball. They all have covalent structures, and they all have high melting and boiling point. Okay, so I am leaving a one question for you people. So why diamond is bad conductor? Why diamond cannot conduct heat and electricity, while graphite can easily conduct heat and electricity and soft in nature? So now Important thing is you people have to memorize the similarity among these structures: diamond, graphite, SiO2, and buckyball. What is similarity among all? They all are covalent in nature. Okay, so what are the difference between them? You people have to check these answer, and you will explain these answer in my comment box. Thank you very much. Allah Hafiz.